Hi everyone, I'm Mohammed, also known as MHX on the internet. I'm a 3D artist and a generalist, and over the last 14 or so years, I've been covering a pretty wide spectrum on the digital art medium. And here's a quick showreel to share some of that work. So I've been exploring ways to create 3D generative art using tools like Houdini, Octane, and custom toolsets that I've been building. Doing this kind of work at a large scale requires a lot of compute, and it's pretty hard to do on local machines, which is what led me to distributed computing and to our collaborations with Render Network and Dispersed. One of the first real outputs of that exploration is a project called Bitmap, which is what I'm going to talk about today. Bitmap is a generative art project that runs autonomously every day. It's a collection that is expanding daily by an algorithm that picks up a block from the blockchain and turns it into a 3D sculpture of a data tree. It's generated and rendered through hundreds of nodes on the render network and dispersed. The goal of it is to be able to generate extremely high quality rendered generative artworks that doesn't have the quality restrictions of a web-based real-time generative artwork process. Every block on the blockchain contains a set of transactions between a few hundred and a few thousand, and each little block element in the artwork represents one of those transactions. The shape and size of each block is determined by the transaction value, fee rates, and other metadata, so the variety in the output comes directly from the data. The system is designed not to be too strict or constrained. It leaves room for emergent results. If the data has a unique character, it reflects it. So sometimes a block with an unusually large transaction will produce something that looks really different from the rest. And that just naturally happens by the rule sets interacting with the data. A single bitmap piece takes around 35 hours to render on a single NVIDIA 4090 machine. So that's kind of impossible to fit into a daily routine. You need it to be done in under 24 hours. So it has to be distributed across hundreds of nodes with an orchestration layer on top that manages the whole generation system. I'll walk through how that works and some things that I run to along the way that might be useful if you're building production pipelines or generative setups with similar tools. So let me walk through how that pipeline works. There are a few stages to the daily routine. The first step is the daily wake-up call. It starts with a Cloudflare worker that runs a lightweight script to send a job request to the Dispersed API. It contains the hardware specifications required to complete the task, like CPU cores, RAM, GPU, etc., along with an authorization token. That token allows the node to access everything it needs. It's like a gateway to all the credentials the node will use throughout the runtime, like the Render Network API keys, the Cloudflare credentials, and also Telegram API, so it can ping me about its status from time to time. The next step is deployment and hydration. The dispersed node spins up a Docker container that has the entire runtime environment packaged inside, like the operating system, Houdini, Octane, GPU drivers, FFmpeg, and everything else the node needs to create the artwork, basically. After the groundwork is done, the script launches Houdini. The Houdini setup uses a module called PDG, which is the procedural dependency graph. It's an automation module where you can program a series of events to orchestrate the whole generation. It picks a block number, pulls the block data from the blockchain, and runs the procedural algorithm to construct the sculpture, and packages the result as an orbex file, which is an Octane native package that Render Network uses to distribute frames to render nodes. And then comes the rendering part, and this is the heaviest step in the process. It takes around 35 hours on my local machine and 10 to 15 minutes on the Render Network API. Render Network distributes the rendering across multiple GPUs in parallel. PDG in Houdini waits for and assembles the incoming frames into the final 4K video. It also runs a validation step, checking for glitches or broken frames that can happen during the GPU rendering. If everything passes, it moves on. If not, it tries to render the broken frames after a few retries. If the frames are still glitchy, it may rerun the entire batch with a new seed to avoid the problem and start fresh. The script generates all the publishing details like thumbnails, metadata for the NFT platforms to pick up. It updates a live token that reflects the daily generation in real time and creates trailing archive tokens that you can retroactively mint over time. And all of that is updated on the Bitmap's website in real time as well. End to end, the whole runtime takes around 10 to 20 minutes to complete for a 4K video loop with complex shaders and heavy rendering tricks. And for the cost, compared to the other cloud providers like AWS or Cloudflare, each artwork costs about 10 to 15 bucks on those services, and on Dispersed, it's like a few cents per generation. And over a full year of daily runs, that adds up pretty fast. And the system has been running since January 1st without missing a single day, so far it's been pretty cheap and reliable. So that's pretty much how the system works. To touch on some of the challenges, getting the Docker image right was a big one. Houdini and Octane both need specific GPU drivers and system configs, so there was a lot of back and forth between my local setup and the container to get everything running smoothly. One of the biggest issues was licensing. Both Houdini and Octane normally require a UI interaction to activate them, which doesn't exist in a default Docker container. It's all terminal based. But thankfully, both tools have headless alternatives. Octane has the unattended licensing, and Houdini has the Houdini Engine license, which both work similarly to an API key. I also had to build fallback mechanisms to make sure the license is always released cleanly, because if something goes wrong, a license can get stuck on a node and you can't reach that node anymore. Another challenge was managing secrets. I wanted the project to be fully open source, including the Docker image, so nothing sensitive could be baked in. For that, I used a callback pattern. A trusted Cloudflare worker holds all the credentials and only feeds them to the container at the runtime within a limited time window. And the container just knows how to ask for them securely using its authentication token. And to wrap up, this was an exploration into building a generative system that gets out of the standard generative art tools and instead uses enterprise production level tools to create highly complex artworks on a mass scale. This process led me to find ways to connect DCCs and APIs in unconventional ways, and that work has already carried over to other projects, like one of my latest works called Lattice for the Submerge event at the Artec House in New York. It was an immersive experience in 18K resolution where overnight distributed rendering and daily iteration through the same system made a project at that scale actually manageable. And yeah, that's all I want to talk about today, and thank you all for listening.